Today's 4-2 in advanced geometry, we're doing the triangle inequality theorem, which says that if you take a triangle, any two sides, it really says any two sides, if you add them together, it will be greater than the third side. So like, I'm going to make up some numbers here in this guy. Let's just use this first problem and see if it works. Wasn't one of them 3, the other one was 4, and the other one was 6, just to make it make more sense with numbers. Let's see. If I take these two and add them together, is 3 plus 4 greater than 6? Yes or no? That's hard to tell. Because don't you need to like combine like terms right there and see that 3 plus 4 is really how much? 7 greater than 6? Now, is that true? And I call this proving it to a kindergartner. All right, a kindergartner would have a hard time saying, I don't know if that's true or not. But if I'd ask him, is 7 greater than 6? I bet you there's a bunch of kindergartners that would say yes. Right? Prove it to a kindergartner. Combine like terms. But that's just these two guys. What if I took like 3 and 6? If I take 3 plus 6 and add them together, is that greater than the missing side, which is 4? Is 9 greater than 4? Yes or no? That worked. And what if I did 4 plus 6 greater than the third side, which is 3? Isn't 10 greater than 3? Isn't each one of these individually like bigger than 3? Isn't 4 bigger than 3? That better work. So the triangle inequality theorem says you're supposed to take all the combinations, add them together, and see if two sides add together to be greater than the third side. That's a bunch of bogus nonsense. Because how it really works is if you take the two small sides, right, which we did with our spaghetti. If you take the two small guys and add them together, see if it's bigger than the third one. Because check this out. Isn't this dude, like I said, already bigger than 4 in the first place? Weren't each one of these bigger than 3 in the first place? This was the true test because 3 is not bigger than 6 and 4 is not bigger than 6. But if you take the two smallest sides, which are 3 and 4, you got to see if it's bigger than 6. So it says, is it possible to form a triangle with these side lengths? If not, explain why. We will do all of our explanations with algebra. Here's our 3 sides, which are the two smallest. So you will set this up for me. 3 plus 4 greater than 6. Now, honestly, here's what we're really doing. The mechanics behind it say you should put a question mark above this because you're questioning the fact, is 3 plus 4 greater than 6? I'm not going to make you put that question mark there. Okay, if you want to, go for it. But we really don't know yet. It's like the question is plus 4 greater than 6? Combine like terms. Prove it to a kindergartner. You get down to 7 greater than 6. Now you answer the question, is 7 greater than 6? Yes or no? So you say yes. The question was, can these 3 sides form a triangle? We answered yes. They say, explain why or why not. We just explained why right there with our algebra, that 7 is greater than 6. The two smaller sides add together to be bigger than the third side. Next one. What are the two smallest sides? 8 and 8. Let's add them together and see if they're greater than the third side. What's 8 plus 8? I should put an 8 there. My bad. 8 plus 8 greater than 8 is what we're checking, correct? And then is 16 greater than 8? Yes or no? Yes. Could you tell me what kind of triangle has side lengths of 8, 8, and 8? That's an equilateral triangle. Next guy. What are the two smallest sides? Don't always assume it's the first two numbers listed, right? You got to really check to see which ones are the two smallest. So we'll take 4 and 8 and add them together and see if that's greater than the third side, which is 16, correct? What's 4 plus 8? That's 12. Is 12 greater than 16? Yes or no? So we got to do this. We got to cross that dude out. 12 is not greater than 16 and put a no. That was the first example that I did with you for spaghetti. For those of you on the video who are like, what are you talking about with spaghetti? It's in class when you weren't here. But with the first example of spaghetti, weren't those two pieces too short, right? Compared to that one piece was too long. It didn't make a triangle out of the situation. These two are too short for this third side right here to form a triangle out of that situation. 2 more. Get them done. Take the two smaller sides and see if they are bigger than the third side. So pause the video and get that done. We got to the point here to where we got 15 greater than 15. Yes or no? No. Cross it out. Because that's when we did the two pieces of spaghetti that were like equal to that third side. It didn't make a triangle, right? They didn't add up to be greater than. And this one, 2 plus 4 greater than 5. That'd be 6 greater than 5. Yes or no? You could have a triangle with side lengths 2, 4, and 5. You could have a triangle of 6, 9, and 15. Some of you might be thinking, I thought that like you're supposed to square the two small sides and see if that equals the third side squared. What does that check for when you take a squared plus b squared just equals c squared? What's that check for? It is the Pythagorean theorem, but what does that check for? If it's what kind of triangle? If it's a right triangle, the Pythagorean theorem will work. It can still be a triangle, but it might not be a right triangle. Would this be a right triangle? There's 2 squared plus 4 squared equal 5 squared. What's 2 squared? What's 4 squared? And what's 5 squared? Does 4 plus 16 equal 25? So that's not a right triangle, but is it a triangle? Yes, it's just not a right triangle. Pythagorean theorem didn't work. Next! Find the range for the measure of the third side of a triangle given the measures of the two other sides. What? Find the range. Okay, so like a whole range of numbers, if you will, right there, for the measures of the third side of a triangle. Let me draw this, sketch a picture. It's the old when in doubt, sketch it out kind of situation. For number 7 right here, they got side lengths of 1 and 6 on a triangle. So here's a rough sketch of a triangle right there. There's a triangle. You know one side is 1 centimeter long and the other one is 6 centimeters long, correct? They're saying, what's possible for this other one? Would any number in the world work for that guy? No. So which numbers don't work? 6 and below is what some people said. You don't think 4 would work. What's 1 plus 4? 5. Is that greater than the third side? Would 2 work? No, 1 plus 2. So 6 and below is what you're saying doesn't work. Where did you come up with that? Would 5 work? No. Would 0 work? Can you have any negative numbers in there? No. Would 6 work? If we put a 6 in there, 6 plus 1 is, so that's greater than this guy. Would 5.5 work? What's 5.5 plus 1? 6.5. Is that greater than 6? That kind of throws out your 6 and below thing, right? Because 5.5 is below 6, isn't it? Oh, you said 5 and below? Okay. What about 100? Would 100 work for this guy? Can I put 100 in this guy? If I do put 100 there, what are the two smallest sides? 1 and 6. Did they add together to be greater than that guy? 1 plus 6 is greater than 100? Is 7 greater than 100? Is 100 a possibility for this guy? Nope. What about like, I don't know, 20? Would 20 work for this third side? 1 plus 6 greater than that? Nope. What about some other number? Like, would you agree that there's numbers that are just too small for this guy and there's numbers that are too big? So how many boundaries do we really have? 2 boundaries. Here's what we'll do. Our third side, we're going to call it x every single time. Start with an x, and it's like in the middle of your answer right there. Start with an x. Our third side is x. There are numbers that are too big and numbers that are too small, correct? So here, let me just get you an answer real quick. We'll kind of do this, then talk about it when we're done. X is in the middle. These symbols. Those are less than symbols. Here's the way I want to explain it. Which way do they point every single time? Both of those are pointing which way? To the left. We need to find the smallest boundary. Smallest boundary. How do you do that? You take these two numbers and subtract them from each other. What's 6 minus 1? 5. So that number goes on the left. The smaller number goes on the left. I found the smallest boundary by subtracting those numbers. How can I find the bigger boundary? Add those numbers together. What would you get? 7. The question is, can I put equal to bars on this? This is like a less than symbol. Should it be less than or equal to? Let's see if 7 works or if 7 doesn't work. First of all, this right here, let me read it to you. It says the value of x, that missing side, if I cover this up, let me get my coverer-upper real quick. That's not my coverer-upper. That's my coverer-upper. If I get rid of the boundaries, whatever. If I cover that up, does everyone know what that says right there? What's that say? X has got to be less than 7, correct? If I cover this up, you got to read from the variable first. Here's X. What does that say? X has got to be greater than 5. When I take my coverer-upper away, it's got two boundaries for me. It says that third side's got to be less than 7, but at the same time, it's got to be greater than 5. This is called a compound inequality. Read from X. X has got to be less than 7, and X has got to be greater than 5. So pick me a number that's less than 7 and greater than 5. I chose 5.5 before. Isn't 5.5 bigger than 5? Isn't 5.5 less than 7? And didn't that work right here? The question is, will 5 work? If we put 5 in here, will 5 make a triangle out of this situation? 1 plus 5 is 6, and that's not greater than 6, so should I put an equal to bar with that bad boy? Would 7 work for a triangle? If I put a 7 right there, aren't the two smallest sides 1 and 6? Add them together, is it greater than that guy? So do you put an equal to bar with this one? So what's the range of numbers? Those numbers got to be greater than 5, but at the same time less than 7, and we'll put a label on it. What's the label that we had with this bad boy? Centimeters. Moral of the story, for these problems, it's so simple. X goes in the middle. Find the smaller number by subtracting the two values. Find the larger boundary by adding them. And these symbols always point to the left, and they will never have equal to bars. So let's do it again. X goes in the middle. Which way do the symbols point? To the left. Smaller boundary. If we got a triangle with side length of 12 yards and 18 yards, what's the smaller boundary going to be? 6, because I took 18 minus 12, right? What about if you took 12 minus 18? You'd get a negative 6. Always take the big number minus the smaller number. Does that make sense? And how do you get the bigger boundary? You add them together. What's 12 plus 18? 30. Then the label, you just put it once. It goes off to the right. Yards. That third side could be anywhere that's less than 30 yards, but at the same time greater than 6 yards. Sound all right with that? Do it again. Let's do 9. X goes in the middle. Symbols point which way? And if they're pointing to the left, that means the smaller number goes on the left and the bigger number goes on the right. Find me those two boundaries. Subtract the numbers and get a 4 or a 3. What do we get? Okay. Add them together and you get a 7. Label. That's the biggest mistake, is we forget the label. One more. Find me the range of numbers that work for that third side. I got a piece of spaghetti. I could break it in any one of these places that fits in this range and make a triangle out of it. If one piece was 82 and the other piece was 8, the third and final piece could be anywhere between 74 meters and what else? 90 meters long. That third piece of spaghetti, if this one is 82 and that one is 8, anywhere between 74 and 90 works for that. Angle-side relationships. They get together so well. Super simple. In a triangle, the longest side is opposite the largest angle. Right? It's just a rule. Like when you make a triangle, the largest side that you got, right across from that, that'll be the largest angle. And etc. The smallest side is opposite the smallest angle, and the quote-unquote medium side, the one in the middle, is opposite the medium angle. List the angles and sides in order from smallest to largest. So let's do that. Here's what I like to do. I like to put tick marks to help my eyes. Can you tell we have all 3 side lengths? What's the shortest guy that you got? Put a single tick mark on it. What's the medium guy? Put 2 tick marks on it. And the long guy, 3 tick marks. Hey, does that even work? Are all 3 of those sides different lengths? So that's what the tick marks are all about. Short, medium, long. So it says list the angles and sides in order from largest to smallest. We can list the sides right away. Which one's the shortest side? If I put RS, is that what you want? What do you want? Segment RS. Medium guy? Segment TS. Could you call it segment ST? And the long guy, segment TR. Right? There's all our sides. That was pretty obvious, shortest to longest. We got to do the angles also. Which one is the shortest side again? This one tick mark guy? Look right across from it. Isn't this the angle opposite it, if you will, right across from it? That's the smallest angle because of what this says. The smallest side is across from the smallest angle. So if we're going from smallest to largest, what's our smallest angle in this bad boy? And here's what I want you to do. Watch this. Put one arc mark in that guy. Angle T. What's the medium angle? Well, it's across from the medium side. Isn't our medium side the guy with two tick marks on it? What's right across from that? Angle R. Put two arc marks in that one. Angle R. And the large guy is across from the large side. Isn't that angle S? Put three arc marks in that. Neato burrito. Away when you're done, you could check if you did it right. If this is the short segment, segment RS, which letter is not involved with segment RS? T, isn't that the angle that we had right here? This is segment TS, which letter is not involved with segment TS? R. Segment TR, which letter is not involved in segment TR? S. There's only three letters possible, right? So that's how you can tell real easy that you did that's correct. Next guy, we got angles. Let's mark them up. Shorty with 1, medium with 2, and big boy with 3. Cool? I'm going to go put tick marks on it before I start answering the question. I want short first. Isn't the shortest side across from the shortest angle? So one tick mark goes on. Boom. Right? Segment RS. 2 tick marks goes across from 2 arc marks, because that's medium and medium. And long boy goes across from triple guy. Now, write them up. Sides first, angle second. Short to large. See how I did it on top of each other also. Pretty simple game right there, right? One more. Get 14 done with your pal. That ends pause the video. My question to you is, if you got that right, do you understand this concept enough to where we don't have to do those other 3 problems down there? Short across from short, medium across from medium, long across from long. Marking before, yes or no? Do you know where the median is on the interstate? It's right in the middle between the 2 highways. One goes east, the other goes west, or whichever direction. Isn't the median that ditch in the middle, if you will, correct? Median of a triangle, very close to middle. But we don't have the word middle in geometry. What's a cool word that kind of means middle in geometry? What's that? Starts with an M. It starts with a mid. Mid point. It's a segment from a vertex of a triangle. You'll need your geometer here shortly. It's a segment from the vertex of a triangle to the midpoint of the opposite side. It is a segment from a vertex of a triangle to the midpoint of the opposite side. 18, draw scalene triangle ABC with median, segment AM. What's a scalene triangle? No sides the same. Number 2 on your geometer is the perfect scalene triangle. Draw me number 2, scalene triangle. Fabulous. It's supposed to be triangle ABC. We need those vertices. Does it really matter where they go? They don't tell us, so let's just all do it the same. How about A, B, C? Did I draw that as a scalene triangle? What do I need? So all different tick marks as well, correct? So all I did was satisfy this part. There's, excuse me, I got the hiccups. Scalene triangle ABC. I need median, segment AM. If the median's name is segment AM, and a median goes from a vertex, which is a vertice, of the triangle to the midpoint of the opposite side, And our triangle has vertices A, B, and C, and this is supposed to be median segment AM. Which vertice of our triangle should we go from? It got to go from A, correct? Its name is segment AM. So I need to go from A, which is right here, and where do I have to draw this segment to? The midpoint of the opposite side, over here, correct? So let's do that. Let's just kind of do a nice little guess of where we feel the midpoint is, like so. That looks to be smack dab like it's in the middle. They want this point's name to be what again? M. And how would I mathematically know that I went to the midpoint by our picture? How do you know that you really drew the midpoint? You need tick marks. We've already used 1 tick mark, and 2 tick marks, and 3 tick marks in this picture. What's the next amount of tick marks available for us? So we got to go 4 guys here and 4 guys there, just so we know that nothing was really the same length in the first place. You know, it was scalene, so 1, 2, 3 different side lengths. Midpoint, I don't know any of these lengths, so we can't assume that they might be the same as some of those others. So you see how that is median segment AM. Is that the only median that we could draw in this triangle, though? You shaking your head no? Where else could I have drawn a median from? Start with B. Now remember, this problem is done. Please don't draw anything after that. But could we have drawn a median from segment B, from vertex B? And if I put it right there, if my thing would want to work, and if I called that like X and did 5 tick marks, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, isn't that also a median? Because that's a segment that went from a vertex of the triangle to the midpoint of the opposite side. Would there be any other medians that I could like draw in this puppy? I could draw one from C, right? So if I would know what I'm trying to do here, and if I went here, and then I called that like Y or whatever, and then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Isn't that a median also? How many medians does a triangle have? It's got 3 medians. Ooh. See that cool point right there? That's called something special, which we don't need to know, but someday maybe you need to know what the circumcenter is. Cool. Next guy. Draw an isosceles triangle XYZ with vertex Z and median segment MZ. One thing at a time. Which number on our geometer is an isosceles triangle? Number 1. Come here. Whoa. Oh, that disappeared. They want it to be called triangle XYZ. Does it matter where those go? Draw isosceles triangle XYZ with vertex Z and median segment MZ. It kind of matters, because we know based on our shape number 1 that these 2 sides should probably be the same. Like there's my isosceles triangle, correct? Those are the sides that are like supposedly the same. And then here's the next question before I start putting the letters in. Should I put 2 tick marks down here? Don't. You don't know that this side's not the same as these 2. Watch this. If I did do this, is that an isosceles triangle? Yes or no? Is this an isosceles triangle? Yes. Because someday we might start with something like this and then prove that it's an equilateral triangle. So we don't know anything about this guy. We can't put 2 tick marks down here. We can't put 1 tick mark down there. We just put nothing on it because we don't know anything about it. Does that make sense? We don't know if it's the same or not the same. It could be the same. It could not be the same. Z is the vertex. Where does that go? Does it always go on the top? It goes where the 2 sides of the same touch, correct? Is this a Z? No, that's a 2. Boom, that's a Z right there. X and Y mean no difference. You could switch those 2 around, but the Z had to go where the 2 sides of the same touch because it's the vertex. Draw median segment MZ now. Draw median segment MZ. Which vertice of our triangle would we go from? X, Y, or Z? From Z. It's got to go to the midpoint of the opposite sides. So now, boom, 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 boom. How come I didn't use one tick mark? I already had one tick mark used. Got to use a different amount of tick marks. Excelente? That's a median. Median, midpoint, median, midpoint, median, midpoint. Boy, if we could stop there, we'd be really good at medians. What's a median? Midpoint, median, midpoint. But now, Confusion City. Altitude. Have you ever been in an airplane before? If you haven't, that's okay. Have you ever heard, like, pilots get on the old radio and go, "Attention, ladies and gentlemen, today we are flying at an altitude of 30,000 feet." You ever heard somebody do that? You're flying at an altitude of 30,000 feet. What's a cool another word for altitude? Height. Altitude of a triangle. This, maybe. A segment from the vertex of a triangle. Perpendicular to the opposite side. It is a segment from the vertex of a triangle perpendicular to the opposite side. A segment from the vertex of a triangle perpendicular to the opposite side. It's a segment from the vertex of a triangle perpendicular to the opposite side. It is a segment from the vertex of a triangle perpendicular to the opposite side. Another word for altitude in our own, guys, is height. I drew an awesome little guy with a super long neck right here. Let's find his height. I'm doing this for the video people because I'd rather do it on myself in person, but they can't see me. Let's find this guy's height. So here's my tape measure. I got my tape measure. Here you go, dude. Let's measure how tall you are. What I take my tape measure and measure to right there. What do I do that? It's like, here's how tall you are. From here to here would be like how tall you are. Does that make any sense? Nope. Don't we like to measure from here to like right there and see how tall that person is right here? This guy. And take a wild guess what this segment and the ground have in common. What's the relationship between the segment and the ground? It's perpendicular. We'll always assume that the ground is flat and that we measured straight down. But that's how you measure height. You go from the top to the bottom perpendicularly. Correct? What's the magic word in altitude, a.k.a. height? Perpendicular. Draw scalene triangle ABC with altitude segment BD. Hey, scalene triangle ABC, I just drew you. A, B, C, scalene. It's so different on every side. Scalene. I could be a great songwriter. I need altitude, segment BD. Which vertice does it got to go from? From B, right here. And where's it got to go? To the other side. Where at on the other side? To the midpoint on the other side. I think that's a median. Where's it got to go? Straight down, I hear you. It's got to go to the other side, and it's got to touch it at a right angle. So don't we just want to, quote unquote, go straight down, if you will, like right there. I need this to be a D. And did I go perpendicular to the opposite side? I can't tell. There's only one way to know if it was perpendicular to the opposite side. What do I need in that picture? Right angle box. This is the altitude of that triangle. It is the height of that triangle. Every triangle has 3 altitudes also, but our brains aren't ready to see the other 2. It hurts the brain. Let's just get used to an altitude being perpendicular like this for right now, then we'll work our way into seeing the other 2. But let me show you this. Let's use a different color. Purple. M. 1, 2, 3, 4. 1, 2, 3, 4. What's segment BM in this picture? Is it a median or is it an altitude? It's a median. What's segment BD in this picture? Are they the same thing in this particular triangle? Is that median the same as that altitude in this triangle? No. What kind of triangle was this? It was a scalene triangle. and I drew a median from point B, and I drew an altitude from point B, and they weren't the same thing in this scalene triangle. 22. Draw isosceles triangle XYZ with vertex Y and altitude segment YD. Get it done. Pause the video. Get that draw written. I got my XYZ. Y is the vertex. It's isosceles with these markings. Now I need altitude YD. Means I got to go from Y. And where am I going? If it's an altitude, where am I going? Perpendicular to the opposite side. Need a right angle box. They want that point to be a D. Fabulous? 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 Are you okay with that? Cool. What kind of triangle is this? It's isosceles. We just drew an altitude, correct? We just drew an altitude. Watch this. Watch me draw the median from Y. There, I drew it. The median I just drew went from Y to the midpoint of the opposite side. What do you see if this is an isosceles triangle? I drew an altitude, then I drew the median. What do you see? Here was the altitude, and here was the median. What did you see? How many segments? 2 different segments. What kind of triangle was this? Here's the altitude. Here's the median. How many segments do you see? What kind of triangle was that? What did you notice about the altitude from the vertex of the isosceles triangle and the median from the vertex of the isosceles triangle? They're the same thing. And that's the only time that a median and an altitude will be the same thing. If the triangle was what kind of triangle to start with? What kind of triangle? If it was isosceles to start with. If that was an isosceles triangle of those triangles, I gave you the formula because it's still kind of new to us. Area equals 1/2 base times height. Ooh, that's a cool thing. Height. Awesome. Height. What's another word for height? Altitude. Look at that triangle. What kind of triangle is this bad boy right here? It's isosceles. Which one's the vertex? Y. Draw me the altitude from Y. Doesn't it go perpendicular to the other side? Perpendicular to the other side. Call that H. And then we need to find H. Correct? How long is this guy right here? That's 12. So let's do some 12 squaring plus some H squaring equals some 16 squarings. Nice. 12 squared is 144. I'll help you because we're running shy of time. 16 squared, anybody know? 256. You can punch that in if you don't know. Subtract. This would be a 2. That would be a 1. That would be a 1. Do we get 112? Is that right? I just did that in my head. Is that right? H squared equals 112. So then H equals the square root of 112. Time to work backwards. 121 is too big. 100, does that go into 112 evenly? 81, help me out because I don't know it off the top of my head. 81? Nope. 64 go into 112 evenly? You just punch in 112 divided by 64. Do you get a whole number? Nope. Does 49? What's below that? 36? Does 36 go into 112 evenly? And how about 25? I know that 25 doesn't go in there. That doesn't end with a 5. Does 16 go in there evenly? How many times? So 16 and a 7, correct? And my height is really what then? 4 square root of 7. And then we stop there because we think we're done, but we're not done. They said find the area of the triangle. All we did was find the height of the triangle. Write the formula down first over here. New set of work, right? Area equals 1/2 base times height. My area will equal 1/2, and here's the trick. We got a height, correct? Now you got no choice of which one's the base. the base and the height must be perpendicular to each other. Here's our height right here. Which segment is perpendicular to it? The 16, the 16, or the 24? 24 is our base. Be very careful that you don't accidentally use 12 again, right? 24 is the whole base, times our height, which is 4 square roots of 7. And here's how you roll. You can multiply numbers with numbers and radicals with radicals. These are all numbers. 1/2, 24, and 4 are all numbers. Do you know what half of 24 is? 12. It's 12. Then take it times 4 also. What's 12 times 4? 48. And the radical just comes along for the ride. Boy, this pen is not very, sorry, this pen is all over the place. So it's 48 radical 7. Sorry if you can't, let me rewrite it. This pen is not a good pen. 48 radical 7. Now, we want to approximate that also. Punch it in your calculator. 48 times the square root of 7 is about, rounded to the nearest tenth. 48 times the square root of 7. 126 point what? Oh, so it would be 127 point what? 0.0. About 127.0. We need a label with area. Do they provide us a unit of measure up there, like inches or feet or anything like that? So we will just use units. Should it be units squared, units cubed, or units to the first power if it's area? Units squared. Sorry that I was Russian, but that's part of my heritage. I'm Volga German.